What if I told you that right now, at this exact moment, an enormous object, roughly the size of a mountain range, is racing through our solar system at more than 210,000 kilometers per hour, and the world's best scientists still cannot fully explain what it is doing? Not NASA, not the European Space Agency, not even the most advanced observatories on Earth. Something about this object refuses to fit into the models we rely on to understand the universe. And the deeper astronomers look, the stranger the story becomes. Right now, a cosmic mystery is unfolding that challenges everything we thought we understood about comets, interstellar space, and the objects that travel between stars. The object is called 3I, Atlas, the third confirmed visitor ever detected from outside our solar system. But unlike the previous interstellar travelers we have seen, this one is behaving in ways that scientists simply did not expect. And before we reach the most unsettling part of this story, you need to understand why this object is so unusual. Because most space discoveries eventually settle into a clear explanation, this one only becomes more puzzling the closer we examine it. The story begins on July 1st, 2025, when a telescope network known as ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, detected something moving across the background stars. ATLAS is designed for one purpose: finding objects that might threaten Earth. Normally, discoveries like this are routine. Astronomers spot a moving point of light, calculate its orbit, and determine whether it poses any danger. At first, that is exactly what they believed they were dealing with. But when the orbital calculations came back, the numbers did not make sense. Instead of following an elliptical orbit, the path most objects in our solar system follow, this one had a hyperbolic trajectory. That difference may sound technical, but it changes everything. An elliptical orbit means an object is gravitationally bound to the Sun. It travels in a loop, circling again and again. But a hyperbolic orbit means something very different. It means the object is not bound to our Sun at all. It is only passing through. In simple terms, it came from somewhere else entirely, and it will leave again. Scientists began tracing the path backward, trying to determine where it might have originated. They checked the Oort cloud, the distant halo of icy bodies surrounding our solar system. They examined the Kuiper belt beyond Neptune. Every known reservoir of comets and debris was considered. Nothing matched. The trajectory clearly showed that 3I, Atlas, had entered our solar system from deep interstellar space. That alone would have made it remarkable. But there was more. This object was not only the third confirmed interstellar visitor humanity had ever observed, it was also the largest and most active of them all. Early estimates suggested that 3I, Atlas, measures somewhere between 2 and 6 kilometers across. Imagine compressing a small mountain range into a single object and sending it flying through space at extreme speed. Its estimated mass approaches 30 billion tons, moving fast enough to cross the entire United States in roughly 90 seconds. And almost immediately, scientists noticed something that should not have been possible. In August of 2025, astronomers using the Very Large Telescope in Chile pointed their instruments toward the object, while it was still nearly 4 times farther from the Sun than Earth. At that distance, a comet should remain frozen and inactive. It should be nothing more than a cold, dark chunk of ice and rock drifting silently through space. Instead, the spectroscopes detected something astonishing. A halo of glowing nickel vapor surrounded the object. This was not a faint trace or a measurement error. It was a clear and unmistakable signature of nickel in gaseous form. And that presented a serious problem. Nickel does not easily vaporize. Its boiling point is around 2,913 degrees Celsius. Yet the surface temperature of 3I, Atlas, at that distance from the Sun, should have been roughly minus 150 degrees Celsius. That difference is not small. It is more than 3,000 degrees. Natural sunlight could not possibly heat the object enough to produce vaporized nickel. But an even stranger detail soon emerged. The nickel appeared alone. In planetary chemistry, nickel and iron are usually inseparable. They form together, appear together, and vaporize together. Every comet, asteroid, and meteorite we have studied that contains nickel also contains iron nearby. That relationship is considered fundamental. Except here. The nickel was present. The iron was missing. It was like discovering smoke with no fire. Scientists proposed a theory suggesting that unusual molecular compounds might be breaking apart under ultraviolet radiation, releasing nickel gas at lower temperatures. It was a creative explanation, but there was a problem. No one could identify what those compounds might be. They had never been observed before. The explanation only created more questions. Then the James Webb Space Telescope turned its attention toward the object, and the mystery deepened even further. Webb's observations revealed that the surface of 3I Atlas had undergone a dramatic transformation during its long journey through interstellar space. Over billions of years, high-energy galactic cosmic rays had bombarded the comet continuously, altering the outer layers of its structure. According to research by astrophysicist Roma Mazzolo from the Royal Belgian Institute for Space Astronomy, these cosmic rays had penetrated roughly 15 to 20 meters into the comet's surface. The radiation effectively cooked the outer shell, creating what scientists call a deep irradiated crust. This crust no longer resembles the original ice and rock that formed around its parent star system. Instead, it has been chemically altered by billions of years of cosmic exposure. In other words, the object we are seeing today is not pristine. It is a survivor. Beneath that hardened outer layer may still lie untouched material from another star system, preserved for billions of years under a protective shell created by cosmic radiation, and that raises a question scientists cannot yet answer. What is hidden underneath? Because later in this story, something will happen when the sun begins stripping away that ancient crust, and what astronomers observe next will completely change how we think about this mysterious interstellar traveler. And that moment begins as 3I Atlas moves closer to the sun, revealing clues about its origin that scientists never expected to find. As the James Webb Space Telescope continued analyzing 3I Atlas, astronomers began uncovering clues about where this mysterious traveler might have come from. Comets are often described as frozen time capsules. Their chemical composition reflects the environment in which they formed billions of years ago. By studying the gases released from a comet, scientists can essentially read a record of its birthplace. Normally, when astronomers examine the glowing cloud of gas surrounding a comet's nucleus, known as the coma, they find one dominant ingredient: water vapor. In comets from our solar system, water typically makes up around 80 to 90% of the released gases, with other compounds appearing only in small amounts. But 3I Atlas did not follow that pattern. Instead of water dominating the coma, researchers discovered something unexpected. The object was releasing far more carbon dioxide than water. Not slightly more, significantly more. The usual chemical balance had been completely reversed. That detail might sound minor, but it carries enormous implications. Carbon dioxide freezes into solid ice only under extremely cold conditions, far colder than the environment where most of our solar system's comets formed. This suggested that 3I Atlas originated in a region around its parent star that was colder than anything we typically see in our outer solar system. Some researchers even proposed something more extraordinary. Based on certain models, the object might actually be older than our sun itself. Think about what that means for a moment. Our solar system formed about 4.6 billion years ago. If 3I Atlas truly predates that event, it could have been drifting through interstellar space long before Earth even existed. It might have traveled through the galaxy while our planet was still nothing more than dust swirling around a newborn star, long before oceans formed here, long before life began. And now, after billions of years of wandering through the darkness between stars, this ancient traveler has passed through our cosmic neighborhood. But the strangest part of the story had not happened yet. In late October of 2025, as 3I Atlas approached the closest point in its journey around the sun, something dramatic occurred. Astronomers expect comets to brighten gradually as they approach the sundial. Increasing heat causes frozen gases inside the nucleus to sublimate, turning directly from ice into gas and creating the glowing coma and tail that we see from Earth. But what happened with this object was different. Instead of a gradual increase in brightness, the light coming from 3I Atlas suddenly surged. The brightness began rising at twice the previous rate, within only a few days. Observatories around the world noticed the same unexpected behavior. Astronomers Chai-Cheng Zhang from Lowell Observatory and Carl Battams from the U.S. Naval Research Laboratory were among the researchers documenting the event as it unfolded. At first, no one could immediately explain why the comet was becoming so active so quickly. Radio observations soon revealed the scale of the phenomenon. In the 2 weeks leading up to perihelion, the moment when the comet reached its closest distance to the Sun, 3I, Atlas began releasing approximately 5.7 times 10 to the power of 28 water molecules every second. That number is difficult to imagine, but the key comparison is simpler. It was 40 times more water than the comet had been releasing only a month earlier. One scientist described the outflow as being like a fire hose blasting into space. Comets do increase their activity as they warm up, but the rate of change here did not match standard models. The timing also appeared unusual. Something had triggered a sudden shift in behavior. Eventually, scientists proposed a possible explanation. Early in the comet's approach to the Sun, carbon dioxide gas had been escaping from the outer layers of the nucleus. That escaping gas effectively cooled the surface, forming a protective layer that shielded deeper ice beneath. But as the comet continued moving closer to the Sun, the supply of carbon dioxide near the surface began to run out. At a certain point, that protective barrier disappeared. Once it was gone, the water ice buried underneath was suddenly exposed directly to solar radiation. The result was a rapid and explosive increase in activity as the ice began vaporizing at a much faster rate. It was essentially a threshold effect. One material shielding another until a critical moment when the underlying layer was suddenly revealed. And that moment happened almost exactly when the comet reached its closest approach to the Sunday. For most researchers, this explanation was sufficient. Natural processes can produce sudden changes in comet activity. But a few scientists began quietly asking a more uncomfortable question. What if the timing was not entirely random? To be clear, there is no strong evidence suggesting anything artificial about this object. The majority of data still supports the idea that 3I, Atlas, is a natural comet with an unusual history, but its behavior continued producing anomalies that were difficult to ignore. One of those anomalies appeared on October 15, 2025. On that day, the comet passed extremely close to Mars, closer than astronomers had ever observed an interstellar object passing near a planet. The distance was only about 12 miles. To put that into perspective, that is closer than many satellites orbit Earth. This unexpected opportunity allowed scientists to capture the most detailed images ever taken of an interstellar visitor. NASA's Mars Reconnaissance Orbiter used its high-resolution imaging science experiment camera to photograph the object during the flyby. At that range, researchers expected to see remarkable details: surface structures, jets of escaping gas, color variations across the nucleus, and perhaps even clues about the comet's internal composition. But after the images were taken, something unusual happened. Instead of being immediately released to the public, the data was placed under internal review. Scientists who had briefly examined the images described them cautiously, saying the observations could reveal new details about the comet's jets and surface structure. The wording was careful and deliberate. They did not say the images confirmed anything unusual, but they also did not say the data was entirely ordinary. Meanwhile, another mystery was beginning to emerge. Space-based telescopes including SOHO, Stereo A, and the GOES-19 satellite monitored the comet during its approach to the Sunday. What they observed surprised many astronomers. The comet appeared as a faint but clearly elongated glow, but something was missing. There was no visible dust tail, and that absence raised a question that scientists were not prepared to answer yet, because comets are supposed to produce dust. Dust is a fundamental part of how comets behave. As sunlight warms their surfaces, frozen gases turn into vapor and blast away from the nucleus. That escaping gas drags tiny grains of dust along with it, forming the glowing tail that stretches millions of kilometers through space. Every comet we have studied produces some combination of gas and dust. But when astronomers looked closely at 3I, Atlas, the expected dust tail simply was not there. Instead of the familiar sweeping trail of particles reflecting sunlight, telescopes saw only a faint elongated glow, as if the object were releasing gas alone. The absence of solid debris made the comet behave differently from anything scientists had previously observed. That mystery might have remained an unusual detail in an already strange story. But only a few days later, another event pushed the situation into entirely new territory. On October 27, 2025, astronomers at Russia's Space Research Institute were tracking the object when the Sun unleashed one of the most powerful coronal mass ejections of the entire solar cycle. A coronal mass ejection, or CME, is a massive eruption of superheated plasma thrown into space at incredible speeds. These storms carry enormous energy, sometimes strong enough to damage satellites and disrupt power grids on Earth, despite being 150 million kilometers away. This particular eruption was aimed almost directly at 3I Atlas. The comet was about to take a direct hit from a wave of charged particles traveling millions of kilometers per hour. Events like this can have dramatic effects on comets near the Sun. Many of them fragment under intense solar activity. Others break apart completely, scattering into debris that slowly drifts away over time. Scientists expected something similar to happen here, but it did not. When the plasma storm struck, the signal from the object briefly weakened. Then, as observations continued, researchers noticed something remarkable. The comet was still exactly where it was predicted to be. Its trajectory had not changed at all, not slightly, not approximately, exactly. There was no sign of fragmentation, no new jets erupting from the surface, and no measurable shift in speed or direction. Despite absorbing a direct hit from a solar plasma storm carrying the energy of millions of nuclear explosions, the 30 billion-ton object continued along its path as if nothing had happened. That level of structural stability is not something scientists normally expect from what is essentially supposed to be a loose mixture of ice and rock. By this point, researchers around the world were trying to make sense of the growing list of anomalies. Some astronomers remained confident that everything could still be explained through natural processes. After all, our understanding of comets comes almost entirely from objects that formed in our own solar system. Interstellar objects may simply behave differently. Others, however, believed the data deserved much broader examination. Among the most outspoken voices was astrophysicist Avi Loeb, former chair of the astronomy department at Harvard University. Loeb formally requested that all scientific data collected on 3I Atlas be released publicly so that researchers everywhere could study it. His argument was straightforward. Humanity has only confirmed 3 interstellar visitors in history. Each one represents an extremely rare opportunity to study material from another star system. Every piece of data gathered during this encounter could help scientists understand what truly travels between the stars. According to Loeb, that information should be examined by as many qualified researchers as possible. But his request also raised another question. What exactly might be hidden in the data that has not yet been widely discussed? When scientists step back and consider the entire list of observations surrounding 3I Atlas, the object begins to look increasingly unusual. It may be between 7 and 12 billion years old, meaning it could predate our solar system. It has a mass of roughly 30 billion tons and entered our region of space on a hyperbolic trajectory from deep interstellar space. Its outer surface appears to be protected by an irradiated crust created by billions of years of cosmic ray bombardment. Its chemical composition does not match the typical structure of comets in our own solar system. Nickel vapor appears without the iron that should accompany it. The object produced a sudden explosive increase in activity exactly at perihelion. It shows little or no dust tail. It survived a powerful solar plasma storm without measurable change in trajectory, and it passed within only 12 miles of Mars in what some calculations estimate as an extraordinarily unlikely natural alignment. Individually, every one of these details might have a reasonable explanation, but taken together, they create a pattern that is difficult to ignore. Avi Loeb has suggested that if an advanced civilization ever attempted to send probes across interstellar space, they might not resemble the spacecraft we imagine in science fiction. Instead of shining metal structures with antennas and lights, such probes might be designed to look completely natural. If a civilization wanted something to survive billions of years traveling between stars, they might build it from the same materials already present in space: ice, rock, carbon, compound substances that blend in perfectly with natural objects. In that scenario, the only way to distinguish an artificial object from a natural one would be through careful analysis of its behavior. To be clear, most scientists still believe 3I Atlas is a natural comet with an unusual history. There is currently no solid evidence proving otherwise. But the fact that serious researchers are even discussing the possibility shows how little we still know about objects traveling through interstellar space. And the story is not over yet. As 3I Atlas now moves away from the Sun and heads back toward the outer solar system, astronomers continue watching closely. They want to know how its activity will change as solar heating decreases. Will the comet fade in the normal way? Will the chemical signatures in its coma reveal more about what lies beneath the irradiated crust? Or will new surprises appear as it passes near the gravitational influence of Jupiter? What makes this moment extraordinary is not just the mystery itself, but the timing. This object traveled through interstellar space for billions of years. It formed around a distant star that may not even exist anymore. Entire civilizations, if they ever lived in that system, could have risen and vanished long before humanity appeared on Earth. And yet this ancient traveler arrived in our solar system precisely at the moment in history when humans finally developed the technology to detect it. Soon, a new generation of observatories, including the Vera Rubin Observatory in Chile, will begin scanning the sky with unprecedented precision. Scientists expect these instruments to discover 1 or 2 interstellar visitors every year instead of only a few per decade. Each one will carry chemical clues from a star system we may never visit. Each one will help us understand the enormous diversity of objects moving through our galaxy. But right now, one ancient mystery continues its silent journey outward. 30 billion tons of unanswered questions are leaving our solar system at 210,000 kilometers per hour, and every telescope on Earth is still watching. If you want to continue exploring mysteries like this and uncover the secrets hidden across the universe, make sure you subscribe to the channel, like the video, and stay with us for the next incredible discovery waiting beyond the stars.